Hello everybody and welcome to the first real episode of the basic OpenGL tutorial series. In this video we'll be going over some OpenGL shader basics, and if we just go to this image we can see the OpenGL rendering pipeline. So shaders are basically programs that can be used to replace the individual parts of this pipeline. So you can see the boxes colored in orange are the actual parts we can replace with shaders. So we can replace the Vertex shader, the tessellation control and evaluation shaders, the geometry shader and the fragment shader. We won't be focusing on tessellation and geometry shaders in this video, but perhaps in more complex future tutorials. In this video we'll be focusing on Vertex and fragment shaders, which we will need to create a basic shader program. So if we just go, you can read more about shaders on your own if you want. I'll just go over some basics in this video. So once you've done that, we will need to actually get the libraries we need to deal with shaders. So you will need the glue32.library, which you can get from my GitHub repository along with its required DLL. And once you've downloaded those, you can paste your DLL in your executable folder where your executable file lies, and you can paste your library under the dependencies. And you also need the glue.h header, which I've already added in the first episode of this series, so you should now have everything you need. So if we just go to your project properties and under additional dependencies, you can edit this and just add glue32.lib in here, and if you just press OK, now we can actually use glue and GL. So first we'll just include gl.h and then we'll include glue.h. So if we try to run this, you can see we get an error that glh is included before glue.h. So the glue.h requires that we include it before gl.h. It's not really a problem here, but you might stumble upon some related problems when you deal with headers and include files. So once we've done that, we will now create a basic display function. So that we will be using to, let's say for now, just change the color of our display. So if we just create our display function to change the color of our SDL display, we're just gonna call it GL clear color, and we're gonna set this to, let's say, red. Okay, once we've done this, we have to then actually change the color of clear our buffer color to our clear color. So we do this with GL clear, GL color buffer bit. And once we've done this, we can just call this display function in our main loop. But we don't actually want to call this display function, let's say, every time we go through the loop. We actually want to restrict our FPS a bit because we don't want to run this a few thousand times a second. So if we just delay this for 1 millisecond with SDL delay, this will now run at about 1000 FPS. So once we've done that, we can then actually swap the color buffer. So we do this with SDL swap window, which will update the color of our window. So once we do this, you can see we get a red screen, which is exactly what we wanted. Now we can actually play around with GL clear color a bit and, let's say, create a variable that changes with time. So we're just gonna get time in seconds, and SDL get ticks will return time in milliseconds. So if we divide this by 1000, we get time in seconds. So now we're just gonna make a variable from a sign factor, and we're just gonna pass in the time in here. We're gonna make it absolute because the sign returns the value between -1 and 1, and we can't really display negative colors, so we're just gonna pass in the X factor in here. And then we get a nice little animation. So now that we have our display, we'll now actually start writing basic shaders. So first we can write a function that will return our shader program. So we're just gonna create shader program function, and this will take in the source for our vertex shader, source, and the source for our fragment shader, fragment shader source, and we'll actually create a function for creating individual shaders as well. So create shader, and this will take in the type of our shader and the source code, source. Okay, so before I continue, I should also mention that I'm using, if you're running on multiple platforms, it is highly recommended that you use built-in GL variables. I'm using unsigned integers, the C++ variable types, because I'll just be running this on Windows. But if you're running on any other platform, I would recommend you use GL uint instead of unsigned int, for example, and other types as well. So if I just go to definition of this, you can see that it's defined as unsigned integer. So now we can actually go and create a shader. So we're just gonna create an ID. So we can create a shader with GL create shader, and we're just gonna set in the type. So now that we got our shader ID, we can now specify the source for our shader. So we're just gonna create a temporary variable source, and this will be the const char pointer to our C string, and this will be the const char pointer to our source. So now we can specify the source with GL shader source, and this will take in the shader ID and the count for our shaders. So this will be only one shader, and the pointer to our char array. So this will be explicit pointer conversion to source, and we can just set the length to 0. Doesn't really matter. So now that we got our shader source set up, we can actually now compile the shader. So we can call the GL compile shader, and we pass in the shader ID. And now that we got our shader compiled, we can check if there are any errors during compilation. So we'll just create a temporary variable that will hold the status of our compilation. So, and now we can query compile status variable with GL get shader IV, and we're just gonna pass in our shader ID, and the parameter name will be GL compile status, and into our compile variable. So now we can check if the compile wasn't successful with checking if it was GL false. Then we can actually check what the compile status was. So we will actually query another variable, and firstly we'll just have to get the size of our compile status log. So we're gonna create a temporary variable, let's call it length, and we're just gonna, similarly with the compile status, we're gonna get the shader IV, and we're gonna get the GL info log length. So this will specify the length of our compile status. So we're just gonna pass this in the length variable, and now we're gonna create a temporary vector full of chars, and we're gonna resize it to the length. So now we're gonna put our data into our vector with gl get shader info log, and we're gonna pass in the shader ID, the size of our vector, and then the pointer to our length, which I believe you can also pass a null pointer in here, and then the actual pointer to our vector. So we're just gonna call the data, and then we can actually print the result. So we'll have to create a string from this, and we'll just copy the values from vector into our string. And if we print this, what's wrong with this? Maybe I just have to create a temporary variable. Oh, I have to probably include string before I do this. So string. Okay, now everything should work just fine. So now that we've printed our error, we can then just delete our shader because we don't need it if it's not valid. So we do this with gl delete shader, and we just pass in the ID of our shader, and we will return, let's say, 0 because we weren't successful in compiling our shader. Otherwise we'll just return our ID. So now that we have our create program, we can now create 2 of our shaders. So I'm just gonna let's assign this with auto, and we're just gonna call this, let's say, Vertex shader ID, and create shader. The type will be Vertex, I believe it's GL Vertex shader, yes, and the source will be Vertex shader source, and similarly with the fragment shader and GL fragment shader, fragment shader, and pass in the fragment shader source. Now that we got our 2 shaders, we'll have to check if both of them are valid. Vertex shader ID and fragment shader ID. Then we can create a basic program for a basic shader program. So we're gonna create a program ID equals to, we create a program with gl create program. Now that we got our program, we can then link our 2 shaders with our actual shader program. So we attach the shaders to our program ID and Vertex shader ID, and similarly with the fragment shader ID. And once we got our shaders attached, we can then link the program. Similarly with C++, the linking works similarly with this, than with the C++. You can read more about it in the OpenGL specification. So now that we tried to link our program, we can actually check if the link status was successful. So we can again create a temporary variable called linked, and we're gonna query the variable with gl get program iv this time, and this will be the program ID, and the parameter name will be gl link status, and the parameter will be the pointer to linked. So if this was false, if link equals to gl false, then we can again just get the log length. We can just copy this from here, but instead of get shader iv, we'll get the get program iv, and we're gonna pass in the program iv in here, and instead of this no, this will be okay. And instead of shader info, we're gonna get program info. And we're just gonna pass in the program ID, and again, everything should be just fine. And before we actually close a program, we should delete both of the shaders. So gl delete shader with vertex shader ID, and similarly with the fragment shader ID. Okay, we can then just return 0 as our program is invalid. But after we've done this, we can actually, before we return our program, we actually have to detach our shaders from the program. You can look more about this in the OpenGL specification again, but this is highly recommended of you to do. So return program ID, and before we do this, we're just gonna gl detach shader from program ID, and this will be the vertex shader ID and the fragment shader ID. Okay, now we should have our shaders set up. We can now actually write a basic shader. So now that we have our functions, we're just gonna create some global variables, because we won't be working with classes yet. So we're just gonna create a global program ID, and we're actually gonna also create global vertex and fragment shader IDs, because we'll have to delete them at the end of the program. So g vertex shader ID equals to 0, and g fragment shader ID. And we're just gonna replace those two variables with the ones in our create program function. And we're just gonna pass this in, and we're gonna replace all of those. The vertex shader ID and the vertex shader ID. Okay. And once we've done this, before I continue, I will also just delete everything at the end. So I can just, I'm just gonna gl delete shader, the gl vertex shader ID, and also the g fragment shader. Oh, this is just called fragment shader. I'm just gonna replace this with ID. Okay, just gonna go with ID in here, and just gonna replace this in here. Okay, so now that we've done that, we can then just delete program at the end as well. Program ID. Again, as I said before, we will be moving this to a class later, so it doesn't really matter how they look right now. Okay, so to actually create a program, we're just gonna create a temporarily, the initialize function for our program. So in here, we're gonna write two basic shaders. So first, this will be called vertex shader source, and we're just gonna set all of the vertices to their default locations. So this to set the vertex position in the vertex shader, we gotta set the vertex position variable to something default. The vertex position is basically a vector 4, and it will contain the x, y, z, and w values, but I will talk about this in some future tutorials. Similarly with the fragment shader, we're just gonna create a fragment shader source, and in here we're just gonna set the frag color to basically red. It's same as GL position of vector 4 variable type, and GL frag color is actually a deprecated variable, but I will be replacing this in the future tutorials when we'll be talking about some different types of variables in OpenGL shaders. So now that we get our two sources, we will now create a basic program. We set our global program ID to a new program. So create program create shader program, and we're just gonna pass in the shader source, vertex shader source, and the fragment shader source. Okay, now that we got our program, we're just gonna print out the actual value of our program, so we can see if our program was loaded correctly. And we're just gonna call this init function before our main loop. So if we try to run this, we can see our application actually crashes because we haven't yet initted the glue library. So we can do this by calling glue init. And if we try again, you can see we got a program ID, which basically means our shaders compiled successfully and our program ID got a valid ID. Our program ID variable got a valid ID. So if we try to make a mistake in our shader, we get an ID value of 1. Oh, I forgot to return 0 if any of the shaders wasn't compiled successfully. So if we try this again, we now get our mistake printed. You can see the error occurred on the first line, and we get the program ID of 0, which is invalid program ID. So okay, this is it for this video. If you like the video, like it, and if you'd like to see more videos in the future, more videos of this basic tutorial series in the future, or any more complex tutorial series coming in the future as well, you can subscribe to my channel. Anyways, thanks for watching, and I will see you next time. Bye!